Hey everyone, welcome back to another explainer. I'm here on behalf of Forge College. Now, if you hung out with us for the previous lesson, emitting events and transaction logs, you already know the mechanical nuts and bolts of writing an event to the blockchain. But today, we are tackling the absolute million gwei question. You know exactly how to emit events, but should you? That's what we're getting into today in this explainer on events versus returns and the ever so important gas trade-offs. By the time we wrap up, you'll know exactly when to use which tool, all without accidentally bankrupting your users. Let's get into it.
Here's our architectural blueprint for today's session. We're going to open up the smart contract toolbox, map out where data actually lives, calculate the heavy cost of gas, walk through a real-world scenario, and leave you with an ultimate decision guide before our conclusion and next steps.
Okay, Section 1. The Smart Contract Toolbox. Meet the contenders.
So, to build truly cost-effective smart contracts, we really have to choose between three fundamentally different data tools. First up, we have returns. Think of returns like a quick phone call. They're immediate communication channels straight from a called function back to whoever called it. But just like a phone call, they're completely ephemeral. The second you hang up, poof, there is zero public record kept on the blockchain. They are strictly for immediate consumption right there at runtime.
Next up, we have storage, specifically utilizing the STORE operation. Now, if a return value is a quick phone call, storage is your ultra-premium luxury downtown real estate. It is persistent data saved permanently inside the contract state trie. It acts as the absolute authoritative on-chain state. It's permanent, and your smart contract practically owns the deed to it. But because it's so incredibly permanent, you are going to pay a massive premium to the EVM landlord every single time you write to it. It is not cheap.
And finally, we have events. If storage is that luxury real estate, events are kind of like renting a public billboard on the side of a busy highway. They are append-only log entries tucked away inside a transaction receipt. We surface them using the emit keyword, and they're designed entirely for off-chain observation. The upside, they are much, much cheaper than storage, and everyone off-chain can clearly read your billboard. The catch? You definitely cannot live there.
Moving on to Section 2. Where data actually lives. The golden rule of solidity.
What's really fascinating here is how this next concept completely dictates your entire architecture. Before you even think about writing a single line of code, you have to stop and ask yourself a foundational question. Who actually needs to read this data once the transaction is totally finalized? Seriously, your answer to that specific question dictates exactly where your data has to live.
And that brings us to this crucial and honestly almost counterintuitive quirk of the Ethereum virtual machine. Smart contracts cannot read logs. Say it with me, they can't do it. Once you emit an event, it becomes totally invisible to the contract itself. The contract physically cannot go back into its own history and ask, hey, what price did I emit yesterday? It's just gone from its perspective.
So, this leaves us with a crystal clear decision matrix. Using an event, the data lives in the logs, it's completely unreadable on-chain, and it's destined solely for off-chain indexers and websites. Using a return, well, that's sitting right there on the execution stack, readable only at runtime by the immediate caller. But storage, good old SSTORE, that is the one and only way your contract can access its own historical data to enforce rules down the line.
All right, Section 3. The heavy cost of gas. Paying the EVM landlord.
Let's actually check the gas meter and see how these architectural choices impact a user's wallet. If we normalize the gas units just to make it easy, emitting a value is incredibly modest. We'll call it a 1 on our scale. But an initial write to storage? Bam! It's a massive 5. Writing to storage creates this huge spike in costs. And, if your logic dictates doing both, storing the state and emitting an event, you're paying the absolute highest premium on the block.
Now, before you run off and replace literally all your storage variables with events to save a quick buck, hold your horses. Beware, adding the indexed keyword to your event parameters is going to run up your bill. Each indexed 32-byte topic requires its own separate storage inside the log structure, and you better believe the EVM charges extra for every single one of them. So even with events, you still have to be pretty strategic.
Let's move into Section 4, Real-World Scenario. Theory into practice. Let's apply all this theory to a decentralized item marketplace where sellers are constantly tweaking their prices. So, step 1, a seller calls update price. The contract executes an expensive SSTORE to save that new state, and it emits a price-updated event. Step 2, an off-chain indexer reads that cheap event to instantly update the front-end website UI. Then step 3, a buyer clicks purchase, and the contract reads the authoritative SSTORE state to securely verify that price. Say, you often must combine your tools. The cheap event handles the flashy UI, while the expensive storage secures the actual transaction. Now imagine for a second if you tried to be super clever and save gas by only using events, like no storage at all. Well, your contract would have absolutely zero memory of the current price. When a buyer tries to purchase an item, the contract literally wouldn't be able to look up the price because, remember the golden rule? Contracts can't read logs. Doing this would open up a massive window for manipulation and completely break your entire marketplace logic. So definitely don't do that.
Section 5, the ultimate decision guide. Think of this as the engineer's cheat sheet.
Let's synthesize all of this into a foolproof heuristic you can just keep in your back pocket for your daily development. Do you need off-chain observability for a website or an app? Use events. Do you need on-chain authoritative state for your contract to verify later on? You got to use storage. Do you just need an immediate response right back to the caller? Use returns. And if you need both on-chain security and those real-time off-chain UI updates, you've got to store and emit, which means, yep, you have to pay for both.
Which brings us to Section 6, Conclusion and Next Steps, Wrapping Up.
All right, you have officially bridged the gap between knowing how to type out an event and knowing precisely when your smart contract architecture actually calls for one. As we wrap up this explainer on Introduction to Events and Solidity, I want you to take a hard look at your current code and ask yourself this: are you paying luxury gas prices for data that really just belongs on a public billboard? Something to think about. Thank you so much for joining me today on behalf of Forge College. Be sure to head over to forge.college to continue your journey in our Events and Logging and Solidity module as part of the complete Solidity from Zero track. In our next lesson, we're going to get our hands dirty declaring and emitting highly efficient indexed events. Keep building, and I will see you in the next explainer.